Hi guys, today we're going to talk about graphing linear inequalities. So this lesson should be a review for you from Algebra 1, but we want to make sure that you're able to graph linear inequalities because the next lesson that we have after this one will actually deal with solving a system of linear inequalities by graphing. So we want to look at the most basic fundamental graphs of linear inequalities today. We have three basic steps. Step number one, we want to graph the points contained in the function, but don't connect them. So just plot the points as you would if it were a typical y equals mx plus b type graph. Step number two, we want to look at the inequality sign. If it's just simply a less than or greater than, we want to connect the points with a dashed line. If it's less than or equal to or greater than or equal to, we want to connect the points with a solid line. That's very important. Our last step here is to decide where to shade. How we determine where to shade on a linear inequality is we test a point that is not contained on the line. If the point is true, then we're going to shade where that point is contained, and if it is not true, we're going to shade on the other side of the line. So that'll make a little bit more sense here as I work through an example, and you can kind of see what I mean by that. Let's look at example number one. With example number one, we have the line x is less than or equal to -2. So first of all, this is not an equation of a line like y equals mx plus b. You know that this is simply a horizontal line that's going through -2 on the x-axis. So what we want to do is we want to locate -2. What I see here is that x has to be less than or equal to -2. Therefore, it's going to be a solid line, not a dashed line through -2. So I'm going to go ahead and do that. So here's my solid line through x equals -2. Bear with me, it's a little messy. Okay, so there's my solid line. So if this were just x equals -2, we would stop here, but it's not. It's x is less than or equal to -2. So when we graph inequalities, we actually have to shade all of the possible solutions to this linear inequality. So this linear inequality is true for all x values that are less than -2. Therefore, I want to pick a point and I want to test it, right? If I picked x equals 0, right? If I pick this point right here, x equals 0, and I plug 0 in for x, is 0 less than or equal to -2? You would say, no, Miss Powell, that makes no sense. 0 is greater than -2. You're right. So I'm not going to shade on the side of the line that has x equals 0. I'm going to shade on the other side. And what I mean by shading on the other side is simply this, okay? I have colored in, or I have shaded where all of my solutions to this inequality lie. All right, let's look at example 2. With example 2, same concept, except we're looking at y now. Y is less than 5. So we all know that if this were y equals 5, that would be a horizontal line through 5 on the y-axis. However, it's y is less than 5. So I want to locate 5 on my y-axis, but instead of having a solid line, it actually has to be dashed. It has to be dashed because it's not or equal to, it's just less than. So here is where my line is of y equals 5. That should be right on 5, by the way. You can see it's dashed. Now I want to know where am I supposed to shade, right? So I want to look at the point y equals 0. If I plug 0 in for y, is 0 less than 5? The answer is yes. So I have to shade where that value for y is located. So in this case, all of my y values that are less than 5 can be contained in solutions to this inequality. All right, now let's look at example number 3. Now with example number 3, we're actually going to use the steps that I laid out above. So step number 1 is going to be to go ahead and plot the points as though we were plotting the graph of y equals -2x plus 3. So the easiest way that I can think of to do this is to go ahead and plot my b value, which is at 3 on y, right? So here's my b value. Oops. Let me get a different color going here. Right, here's my b value. My slope is -2. So from this point, I'm going to go down 2 and over 1. Once again, down 2 over 1. We can kind of see this pattern emerging. If I want to go up 2 and over 1, I can do that and get a point there. Now, in step number 2, we said to go ahead and look at the inequality symbol. This is y is less than or equal to. So because it has the or equal to marking, I'm going to go ahead and connect all these points on this line with a solid line. Please bear with me, as I know it's not exactly nice and clean and straight. Do you get the idea? Okay, so there's my rough graph. So then the next thing I want to do in step number 3 is I want to actually shade, right? I have to figure out where my solution set is for this particular inequality. So I want to test the point. I want to test a point that is not contained on my line. My default is typically the point 0, 0, unless the line actually goes through the origin. If the line goes through the origin, then I want to use a point that is not contained on the line. Because 0, 0 is not on the line here, it's a good point to test. Now, when I say test, what I mean is this. I'm going to test the point 0, 0. So really what I'm checking for is the validity or the truthfulness of this point with respect to this linear inequality. So I'm going to plug in 0 for y. I'm going to just write my inequality is less than or equal to with obviously a question mark above because I don't know. That's what I'm trying to figure out. -2 times 0 plus 3. So cleaning this up, what I see here is I end up with 0 is less than or equal to 3. Is that a true statement? Yes, of course. 0 we know is in fact less than or equal to 3. Therefore, what that means to us is this particular point 0, 0 is in fact a solution to the linear inequality that we have. Therefore, we are going to shade where that point is on that side of the line. So that's example 3. All right, let's go ahead and look at our last example, which is example 4. Now with example 4, life gets a little bit more interesting because of the fact that this guy is not in an mx plus b form right from the beginning. So there's obviously a couple different ways that you could graph this. You could find the points to this any number of ways. You could use your you could find your x and y intercept, plot them, connect the points with a dashed line. I am going to rewrite this into y equals mx plus b form because that's the process that I think is most useful when doing these. So when I go to rewrite this inequality into y equals mx plus b form, I start with -4x minus 2y is less than 4. My goal is to get y by itself, so I'm going to add 4x to each side. So bring down -2y less than positive 4x plus 4, right? Because it goes positive because it moves to the right-hand side. Now divide everything by -2 to get that y alone. If you're thinking to yourself right now, Miss Powell, don't you need to change the direction of that inequality? You are correct, right? You divide it by a negative, change the direction. So y is greater than -2x minus 2. All right, so y is greater than -2x minus 2. We can go ahead now and we can plot this as though it were an equation, right? So let's plot our b value first. So that's -2. My slope is -2, so I'm going to go down 2 over 1. Down 2 over 1. If I want to plot a couple points to the left of that y-axis, go back up to your b value, go up 2 over 1. Once again, up 2 over 1. All right, so here, these points, my step number 2, right, is I want to look at the inequality symbol. Since it's just greater than, not greater than or equal to, I'm connecting with a dashed line, not a solid line. Okay, so now my last step here is to test a point. Well, once again, I want to ask myself, is it possible to test the point 0, 0? And the answer is yes, it is possible to test the point 0, 0 because it does not lie on that line. So let's go ahead and run our test. So if we test the point 0, 0, so going back, I can go either to my original -4x minus 2y less than 4, or I can go to this one to test my point. Either one, I should be fine. I'm going to go ahead and go to the one directly above it. So I want to know if 0 is greater than -2 times 0 minus 2. All right, so this is my question. Is 0 greater than -2? And the answer is yes. We know that 0 is in fact greater than -2. Therefore, I'm going to shade where the point 0, 0 is, which is above the line. Okay. If you're looking at this right now and you're like, Miss Paula, didn't we already know that? Did we really have to test a point? Can't you just tell that y is greater than -2x minus 2? So you have to shade above the line? Yes, you can. That's absolutely correct. You can do that. Not a problem. I'm showing you how to test the point just so that you can know if it's right every single time without any question. You'll have a great day. See you later.